First of all, I have the hard task of being between you and the drinks, so I'll try to make it interesting, focused, and in case you have any questions, don't hesitate. We'll have time to discuss during the drinks. I'll like first to introduce IMA-Europe, then also introduce the mineral sector, how we move our products from the quarry to their end applications. And I'll focus on the purpose of this event, circularity, value chain, how we actually work with the value chain stakeholder with a few key examples, project opportunities, but also a few takeaway messages. IMA stands for Industrial Minerals Association. We have, and we are an umbrella association, and underneath we had 10 mini industrial associations, and they each and any of them represent one or multiple minerals. The minerals, they are not part of the Mendeleev table. The only thing you have to remember is that they are not metals. Metals, they are in the Mendeleev table, they are not in the Mendeleev table. I'll name a few of them. Silica sand is what you see at the sea. Calcium carbonate is the rocks that you see at the sea, but we also have talc, kaolin, and clays. And when we speak about our members, we have about 250 member companies that operate around Europe. They have 685 mines and quarries around Europe and 750 processing plants. We have more processing plants because sometimes we work at the user site, so this explains why the number is bigger. We have members in EU-27, UK, Norway, Turkey, as well as Switzerland. And we extract annually and we process about 180 million tons of minerals, and we have direct employment of 42,500 people, direct employers, and the number of indirect employers, you can just multiply this value by 2. The turnover of our members is 14 billion euros, which contribute to the EU economy. And I'd like first to thank Chris and Anya also for introducing the mineral sector as well as the use of these minerals as end products, so thanks a lot for that. As I said, I'll not question you on the name of the minerals, but when you see the end products, they have or one or multiple minerals as part of them. So if you see on the table, you have glass, which contains 100% minerals, ceramic as well. Paper, you have 50% is minerals that make it structured, or if you use it in cardboard to make it hard. Smartphone, house. You also saw the presentation just made right now on the new energy project, that they'll need more steel in order to install these new infrastructures. They will also need more and more minerals as part of their steel making, for example. Having said this, what is important is that you can see on the upper part in the photo how a quarry looks like, and this is the end products after the minerals are being processed and they are meeting all the requirements of different end users. Focusing on the circularity, I would like first to start with a few questions on how you can be circular when you have multiple regulatory opportunities or challenges. It depends from where you see things. The same mineral can have multiple functionalities. It can be in different value chains. It can take different time when it is used in a specific application. If you take a glass, it will be maybe 1 year. If you take a car, it will be 10 years. If you take a house, it will be 50 years. So how do you recycle, or how you work across the value chain to recover these minerals? What is done and what can be done, I'll also provide a few examples on how things are being done within our sector, but also along the value chain. And maybe important to start with something which is the policy viewpoint. The policymakers, they think that going from linear to circular, it looks as clean and as sharp and as easy as this one. But we did the assessment internally and we came up, yes, we can be circular, but in order to be circular for mineral sector, and I think it's something that also other sectors can be, it can also apply to different sectors, we need to be, first of all, we should have an economically viable model. We will work towards integrating the management of different resources, and the definition of resources is materials, primary or secondary, energy, heat, water, CO2, and all this to be done along all life cycle stages of the different raw materials. And circularity can be carried out when it is technically, environmentally, and economically practical. And I think it's important to explain a bit what we mean with this. So when we recycle copper, the metals, you go from copper, you recycle copper back. Minerals, you'll never get silica sand out of glass. You'll recycle glass, which is the end product, but you'll never get, economically is not meaningful, environmentally is not meaningful to recover the silica sand out of your glass. So, having said this, this is how our circular model looks like. And I'll just take a bit more time to explain to you why our system looks so complex compared to a policy viewpoint. After discussing with our members, the initial idea is that we have defined 5 business models which are applicable to the mineral sector. The first one is optimized or integrate primary and secondary raw materials, and we can do this at the quarry stage. We can also do it by combining end-of-life waste. The second business model is resource recovery, and this we can do it at the quarry phase if we work with different stakeholders, but also products that contain minerals that can be recycled. The third one is when, thanks to our use of our minerals, we can also deliver a material life cycle extension. So thanks to the use of these minerals, we'll have a product that is going to be used for a longer period of time. Material as a service is when we don't have transport, but as I mentioned, we have cases where our raw material, the finished raw materials, they are used at the site of the user. So we don't have a transportation cycle in between, but we produce where the raw material is actually needed. And industrial symbiosis, where we work with other stakeholders in the vicinity of our site. And having said this, I'll just go a bit and provide you a few case studies how this works in practice. The first two ones, they are a bit straightforward, but I'll still like to say that we have just finalized our what we call the recycling sheets, where we have done a mapping of information that has been published by different industry associations in Brussels that represent, for example, the glass producers, the paint producer, agriculture sector, steel manufacturing, or plastic recycling. And out of this, it's obvious that 60% of the assessed applications containing minerals, they are actually collected and recycled. And what we observe is that over the last 5 years, we have 10% more end applications which are being recycled annually in the European Union. And this is a good sign. But the recycling per se, it will not be sufficient to supply the demand for primary raw materials. So in fact, we need primary and secondary raw material to meet the demand by the market. Just to give you a flavor, as I mentioned, the different minerals, they are listed on the left-hand side of the photo, and you can see the major differences from 5 years ago and this year that we finished the assessment. You can see that the average recovery rate has been going on from 7 up to 22%. And the application where we have a high recycling rate of 22%, they are mainly because of recovery of actually construction of the buildings. So now you are better to separate better the flows and to recycle much more qualitative end-of-life products. Glass and paper and steel, these are classical that we know. Plastic, the policy pressure is there. So you see that there is a boost in trying to recover more and better flows in order to valorize them. As I mentioned to you, a clear example is the glass recycling. It can be endlessly recycled without losing its properties. So you can recycle endlessly, but in order to valorize this, you'll need to also include some more primary raw materials in order to do the melting possible of this recycled glass. The second one is a case study where we use hydrated lime, and it was assessed from researchers in the US, in Europe as well, that thanks to the use of hydrated lime, you can extend the lifetime of the hot mix asphalt, which is the top layer in the roads, by 25%, which means that you have to do one recycling or one maintenance stage less, which means you need less raw materials, more energy, less noise for the people living nearby these highways. On the resource recovery, I would like also to highlight a project which was developed by our German members, and this was driven by German law, where the phosphate, which is a critical raw material, was recovered by the end of life from the wastewater purification process. The fourth one, material as a service, this is the precipitated calcium carbonate, which is produced in the paper mill, so not in our side, but on the paper mill side, and there you don't have any transportation, so there you have also some CO2 savings. And last but not least is the industrial symbiosis, which is an APOS project. And in here we had 5 different sectors that were working. They were actually located in the vicinity of an industrial site, notably the steel, cement, chemicals, minerals, as well as engineering. And they were able, by mapping the different flows, they were able to valorize these flows and make a business case for each and any of them. A few more cases that I want to highlight that focus mainly on climate, circularity, as well as recovery of critical raw material that I would like to valorize on the CO2 valorization, cross-sector innovation. The first one is the project named Concrete, which was developed in Belgium. And in here we have a lime producer, a CO2 transport company, as well as a construction company that work together to valorize the CO2 process emissions from one of the partners and make building materials with lower CO2 footprint. So in fact, thanks to the carbonation process, you are able to make the building materials having a low CO2 footprint. And this is in the advanced level of TRL, technology readiness level. And as you see from the figure at the bottom, you have multiple stakeholders that are working together to link these flows. The other project is a project in Finland, and in here you have also a lime producer, cement factory, as well as insulation and construction company that work together to valorize the waste tailing from the extraction and flotation process, and also valorize the blast furnace to develop the minerals for the wool, for the mineral waste wool. And in here you also see that how different stakeholders being located in the vicinity, they are able to develop these innovative solutions. The other case study, which is a bit of a stretch, I will grant you that, is to C4Value is a project, a European funded project, which aim is to cover desalination or valorize desalination waste flow and recover up to 10 different raw materials, notably lithium, boron, magnesium, and few essential raw materials such as calcium, molybdenum, and indium. And the idea of the technology that is being tested by the different stakeholders in the project is to increase the recovery of fresh water from desalination from 50 up to 80%, and in order to valorize the flows that are highly concentrated and be able to separate this critical and or essential raw material. It's a project developed in Spain with the involvement of different research and technology organizations, universities as well. Another project that was important for us to be involved is the valorization of fine particles. So as mining sector, we have always this negative image of a sector that generate a lot of waste. Sometimes it's not that we wish to generate this waste, sometimes the technology is not ready to minimize this amount of mining waste. And with this project, the idea was to valorize the fine particles which are part of the tailings that were not able to be valorized before because the technology was not ready. And in here, we work with different research universities to reduce or to test what is the viability of this new technology for these fine particles. And they were pilot tested in EU, Africa, Latin America, and Asia for different raw materials. And the project was led by a German company, and there were multiple stakeholders, notably research organization, but also company that were part of it. And last but not least, I don't want to be the party crasher, but I would like also to highlight that sometimes try to implement these circular economy solutions. You also face some bottlenecks, notably by the authorities. And I would like to highlight the project Coralis, which is a European-funded project. And when the project proposal was submitted, there was an agreement on the principle with the authority that one of the pilot plants was going to be located in Sweden. However, when the granting was there and the permitting started, the authority did not give the permit because they didn't know what industrial symbiosis was going to work like in the site. So the company, they had an alternative site that they could put forward with other sectors involved, but they faced some major delays due to the permitting bottleneck that was identified in this case. The project is led by Circe in Spain, and there are also multiple stakeholders involved, and all the other pilots, they went as initially planned. Just to close, a few takeaway messages is that minerals that are produced in Europe and for Europe still do matter, and despite the high recycling rate, we'll still need primary and or secondary raw materials, as already demonstrated with the data we have been able to collect. Some of the policy, they widely support the circular economy, and they introduce incentives and measures that can help to achieve circularity, but sometimes you cannot be primary raw material producer and end-of-life recycling company in the same facility. So, or you need to expand your existing permit, or you need to create two legal entities that deal with different parts of primary and the secondary raw material processing. When we speak about circularity, as in the case of this industrial symbiosis project, it is important to highlight the fact that digitalization or harmonizing of the different data set can help to create these informative tools that help you to take decisions within your company, but also help you to have discussions with outside stakeholders in order to make a business case. So data matters, but also the way you present and you manage the data is also equally important. Administration and over-regulation sometimes can hinder the material circularity among European countries or even within the same country. And in here, I have a case study which is really special from the classification of mining waste from steel sector, for example. They are produced exactly the same in the northern part of Italy and the southern part of Italy, but they are classified totally different in both sites. So they cannot move the waste up because it will not actually pass the border. So this is also important to highlight that, yes, we want to be circular, but the tools and the means in place from the legal viewpoint, they should also follow and support this circular move. The last one that I would like to highlight or to have as a takeaway is that there is a change in the way companies were doing innovation in the past, and there is a change in the way they are doing it now. Before, innovation was R&D very closely looped within the lab of different companies. Now they have realized that alone you'll not be able to make a major change. So you need to speak with your neighbor, whether industrial neighbor or whether authority, and be able to open up and create new possibilities. And as I shown in the few industrial symbiosis projects that our members develop, you see that there are benefits where you can create added value for you as a company, but also for other stakeholders. But you need to be able to open up and to make sure that there is a common understanding on what you are trying to do and how the other stakeholder is also dealing with this topic. And with this, I'd like to thank you for your attention. I kept it short, but I'd like to have some more time to actually discuss in person. Thank you.